Let's take a look at what happens when we actually digest food. So food comes in many different forms and varieties, and it can contain fats, and it can contain proteins, and it can contain carbohydrates, and simple sugars even. So the simplest sugar, glucose, is produced by photosynthesis. So if we start with something like that, C6H12O6, and we react it with oxygen, out of that we get carbon dioxide and water and lots of energy. And the question is, how much energy? We can balance this reaction. We see 6 carbons here, so 6 carbons here. We see 12 hydrogens here, so 12 hydrogens here. That gives us 18 oxygens, 12, 18, so there's 6. We need 12 more. So there's our balanced chemical reaction. So we've balanced the atoms. We've balanced the number of oxygen, hydrogen, and carbon atoms, but then we have this energy over here that used to be chemical potential over here. So can we figure out how much energy comes out of this reaction? And the answer is yes. We just have to perform it and measure that energy. So we need a device to measure energy. But you guys are already sort of familiar with one. If you think back, you know the equation Q equals m times c times delta T, where this is the mass of the substance, this is the specific heat of the substance, and this is the change in temperature of the substance. Multiplying all three of those together gets us the heat transferred to the substance. So imagine if we had a container filled with water, and we could burn a sample of sugar or food or whatever underneath it. And so all the heat goes into the water. By measuring the heat gained from the water, if we contained this whole thing, if we measured the heat transferred into the water, we would know that that heat came out of this. And this device is simply called a calorimeter. Okay? And calorimeter has a familiar ring to it. Caloric or calor, that's referring to energy, specifically heat energy. Meter is to measure. So a calorimeter measures heat energy. And it sounds familiar because calories are the energy unit we use to measure the amount of energy in foods. When something says it contains 100 calories or 200 calories per serving, they're actually telling you the amount of energy in a given amount of that food sample. And in a lab, you guys are going to measure how much energy is produced by burning a food sample and capturing the heat in some water. So we're actually going to take and burn something here. We're going to measure how the temperature changes. We're going to measure how the mass of this thing changes. So instead of just figuring out how much heat the sample of water up here gained, we're also going to figure out how much heat it gained compared to the amount of fuel or food that burned, and we'll get this unit of joules per gram. Or if we wanted to, we can convert that to the nutritional speak of calories per serving. Now both joules and calories measure energy, and it turns out 1 calorie is the same as 4.18 joules. So a calorie is bigger than a joule. In fact, originally when people were first figuring out that heat and energy were the same thing, the calorie was defined as the amount of heat required to raise 1 gram of water by 1 degree Celsius.